Okay, today we're going to start by looking at just some of the basics of logarithms. I don't want to go too deep because we're about to go into a break. So we're just going to look at a little bit of the basics and then we'll get deeper when we come back from Thanksgiving. But for now, we're going to be looking at the two skills in IXL, evaluate logarithms and change of base formula. So what is a logarithm? I think the best way to think of what a logarithm is an exponent, right? When we talk about logs, what we're actually looking for is an exponent. And so when we have a log, we have a base, and we're taking a log of some number n, and what we want to know is what do I need to raise b to in order to get the number n? So what exponent can I apply to b that will give me n? All right. So to think of it in another way, I like to say, okay, well, we're looking for something we don't know, so we're going to call it x. So let's say we need to raise b to x to get n, or this is how we can write it. Okay. So the log, again, asks, what do I raise b to in order to get n? If the answer is x, then we can say b to the x is equal to n. This is what's called exponential form, and we'll talk about it a little bit later. But our goal today, our first goal, is to be able to evaluate logs. So let's look at this first one. Suppose I have log base 8 of 64. So I need to be thinking, what do I need to raise 8 to in order to get 64? Okay, so I can rewrite that as 8 raised to what power gives me 64. And of course the answer is 2. 8 to the second power is 2. So log base 8 of 64 is equal to 2. All right, in this next example, our base is 5. So what do we need to raise 5 to in order to get 125? We get 5 to the x is equal to 125. So we can think about that. 5 to the first is 5. 5 squared is 25. 5 cubed is 125. So we need to raise 5 to the third power in order to get 125. All right. Suppose we want to evaluate this log. Okay, notice that this log doesn't have a base that's written. This is what we call common log. And we understand when there's no base indicated that the base is 10. Okay, so we can think of this as log base 10 of 10 is equal to x. Okay, again, when we don't have a base written on this log notation, then the base is understood to be 10. We don't have to write that. It's commonly agreed on in mathematics that the base is 10 when there is no base indicated here. I've written it here just for clarity. But the question is still, what do I need to raise 10 to in order to get 10, right? And so the answer would be 1. 10 to the first power is going to give me 10. All right, so we'll find out a little bit later that the domain of the log function is from 0 to infinity, 0 not included, and the range is all real numbers, okay? And so it's possible that we could get out of a log a negative number. And in that case, it's usually when we've got a fraction here, right? So we still have the same thing. Again, this is my common log. The base is 10. And so I'm asking myself, what do I raise 10 to get 1 over 10? All right, so another way to write that is 10 to the x is equal to 1 over 10, or 1 over 10 is equal to 10 to the negative 1. So 10 to the x is equal to 10 to the negative 1. X is equal to negative 1. All right, so our second skill is going to help us to change the base of our logarithm. The reason we might want to do that is because a lot of times we can't just look at the log and evaluate it as we did in the previous examples. For instance, I can't say what I need to raise 5 to in order to get 45, because 45 is not just a power of 5. It has other factors. And so on our calculator, we have 2 log buttons. One is the common log that we've mentioned. The other is the natural log that we'll talk about in just a second. But, you know, a log could have any number as a base, any positive number as a base. And we just, in order to use our calculator to help us evaluate that, we need to change the base to either common log or to natural log, okay? Now, in the examples that we're going to be looking at, you can already see in this example that they ask us to write it as a quotient of base 6 logarithm, okay? And so we'll be practicing it using different bases, but if we were actually trying to get to the answer, then we would use either common log or natural log, okay? But we'll come back to that in just a few examples. Here, what we want to do, well, let's explain the formula first. We've got log base m of x. So m is going to be my old base, right? And we're going to use n to represent the new base, okay? If I want to change from base m to base n, then we're going to take log base n of x. X over here was the thing that we're trying to take the logarithm of, and we're going to divide that by log base n of m. And again, remember, m is my old base, okay? So let's put some numbers in this. If I want to rewrite log base 5 of 45 using base 6, first thing I'm going to do is kind of set up my expression using log base 6, and x is my 45, right? X is in, or 45 is in the x place, so we're going to put a 45 here, and remember we said m is the old base, right? Since it's a base, it's going on the bottom, and the 45 goes on top. So we get log base 6 of 45 divided by log base 6 of 5. And that's all they want us to do. They want us to rewrite it as a quotient. We don't need to go any farther with this. All right. Again, we're going to rewrite as a quotient. This time we're going to use base 9 logarithm. Okay, and our old base in this case is 10. Right, so, and because this is our common log, no log is indicated, so we know it's base 10. So we've got log base 10 of 24. I want my new log to be base 9, so I've set that up using our example here, our pattern above. X for me was 24, and m is 10. And we're going to leave it at that. So we get log base 9 of 24 divided by log base 9 of 10. All right, here's another one. We've got log base 8 of 20. Okay, we want to rewrite it as a quotient of 2 common logs. All right, so they want us to use, since it says common log, that means log base 10. Okay, so we got log base 8 of 20 is equal to log base 10 of x divided by log base 10 of m. And so 20 was my argument, or it was my x, the thing that we were taking the log of. I put that up top. And 8 was my old base. We got that on the bottom. Here I had written it as log base 10. I actually stated the 10, but again, we don't have to do that. So we end up with log of 20 divided by log of 8. All right, we want to rewrite as a quotient of 2 natural logarithms. All right, again, we're still using our change of base formula. This is the first time that we've seen the natural log. Natural log has base e. E is a constant. It's about 2.7 something. We're going to be talking about it in this unit, but we write it as natural, or we describe it as natural log. The notation for natural log is actually Ln, not NL. So this notation means natural log, and we know that it is a log with base e. Okay. So if I want to rewrite log 47 as the natural log, it's going to be, it's already log base 10 of 47, right? This is the common log because no log is indicated. And then I'm going to use a new base. I'm going to use log base e, top and bottom, right? And we're going to take the natural log of 47 divided by the natural log of 10. Okay, again, Ln is log base e, and we call it natural log. Okay, natural log is the same thing as log base e. All right, here's another one. This one we want to rewrite as a quotient of 2 common logarithms. Again, common log is log base 10. So we're starting here with log base 4 of 9. Okay, and I set it up. I've got log base 10 of x over log base 10 of m. This is our formula. Okay, and so my x was 9 and my old base was 4. So we get log of 9 divided by log of 4. All right, this one is a natural log, and we want to rewrite it as a common log. So we know that natural log is log base e, right? So this is us writing it all the way out without using the natural log abbreviation. All right, log base e of 36. I'm going to common log, so the base is going to be 10, right? And the thing that we were taking the log of is 36. We're going to divide that by log base 10 of e, where e is our old base. Okay? All right, so this is our last example, and it actually takes us back to the first scale. We're not just rewriting as a quotient, but they want us to evaluate this particular log. Now, in that section, we didn't know about change of base yet, right? So I was surprised to see this problem come up in that skill for IXL. But now that we know about change of base, we can actually evaluate this, okay? Remember, I was saying that, often if I want to know what I need to raise 8 to in order to get 3, then I want to change my base to something that's on my calculator. I have on my calculator, if you look probably on the left side of your calculator, to the left of the numbers or somewhere in that area, you'll see a key that says log, that's L-O-G. You'll also see a key that says Ln, natural log. So you could change it to either one of those because we have those keys on our calculator. All right, so I'm going to change log base 8 of 3 to the common log, or log base 10. All right, so we got log base 8 of 3 equals log base 10 of x divided by log base 10 of m, where my x is 3 and my m, my old base, is 8. All right, so we would go one step farther here and we would actually type this into my calculator. I would type or hit the log key. I'm doing it on my calculator now. Okay, when I hit the log key, I get a left parenthesis. I'm going to enter 3 and close parenthesis. I'm going to do my division key and hit the log key again and an 8 and close parenthesis. So I've got log 3 divided by log 8. That comes up to 0.528. So if you wanted to check that out, if we take 8 and raise it to everything, not just the 0.528, but all the decimals there, then it will come up to 3. Okay, if you do some rounding, then you're going to get a bit of an error. But it should be very, very close. All right, so we can say that log base 8 of 3 is 0.528, and we used our change of base formula to help us with that. Okay, now you can try the skills that we mentioned in IXL. If you have any questions about this, then you can come on Monday and get some help with that. We can talk about it then. And if not, I'll just see you at our next class.